Hello, all dear friends. I, Abhinav Negi, welcome you all in this super animated series, very interesting series, the Ground Zero series, where we will be telling you very interesting concepts through animated videos. Today, I'll be telling you about shear force diagram and bending moment diagram, SFD and BMD, its significance, its importance, and the trick. Now, SFD and BMD is termed as shear force diagram and bending moment diagram. But before drawing the diagram, let us understand what actually is shear force, what actually is bending moment. Now, suppose this is a beam and in this beam various forces are acting. I am considering the beam to be in most general case. Vertical loads are coming, horizontal loads are coming, horizontal loads in other direction is coming, inclined loads are coming, movement is coming, everything is coming in this beam. Now, in this beam, if I draw a section, but before telling you drawing the section, let me tell you there are three axes. One is x and y axis. X and y axis is that axis which is passing from that plane only. So they are transverse axis which is passing from that plane only, and which is coming out of the plane, that is the longitudinal axis. So axis passing from the plane only are transverse axis and the perpendicular to it is longitudinal axis. Now suppose this is any beam and I cut it in two parts, xx. Now naming this as one part, this is as two part. I have cut this beam into two parts. I am drawing the free body diagram of any one part. Let me take this as one part. This is half of this. Okay, might not be exactly half, just a partition. Okay, so I am drawing the free body diagram of one part. Okay, and in one part might be some force is acting here also. In this one part, here I am telling you, so let here one more force is coming here. So drawing the left hand side part, that is the one part, it will be something looking like this. Now there are the axis xx, yy are transverse axis passing from the plane only, and zz axis is the longitudinal axis. Now listen to me very carefully, guys. I will be telling you now the significance of shear force and bending moment. See, earlier the whole beam was in equilibrium due to its supports. So small part must be in equilibrium. If Abhinav Negi is in equilibrium here, my nose is also in equilibrium. It is not going to Khandala. So this is the small part one, that is left hand side of xx axis. So it has to be in equilibrium. Now there are three axes, xx, yy and zz. Now from the left hand side, whatever the net force vertically in y direction, the same force has to be upward. Whatever is the net force vertically downward, the same force has to be upward to make it balanced. Okay, whatever is the force in x direction inward, that has to be in opposite direction to make it balanced. Similarly, the net force in z direction, it has to be y opposite force to make it balance. This is Sy and Sx and Sz. So three internal forces. Why I'm calling them as internal forces? Because this we obtained after cutting the section. So after cutting the section from here, we are getting these forces Sx, Sy, Sz to balance it. Might be some of the force, if suppose only vertical loads are coming, so only Sy will come, Sx and Sz will be 0. Suppose only this type of loading is coming in x direction, so only Sx is coming, Sy and Sz will be 0. Right now I am telling you for the most general case, Sx, Sy, Sz, all internal forces will be coming, and they will be coming in such a way that the net force will be 0 for this part. If whole body is in equilibrium, small part is also in equilibrium. Now, not only forces, guys, force causes movement also, force into distance. This force is causing movement also about y axis, and same for other forces also. So movement should be coming mx, my, mz to balance, to make the net body in equilibrium. So here will be coming everything, Sx, Sy, Sz, and movements also, mx, my, and mz. So after cutting a section for the most general case, where loading, movement, everything is coming, we get six things, three forces, Sx, Sy, Sz, and three movements, mx, my, mz. Out of these three forces, you can clearly see that Sx, the force in x direction, and Sy are tangential to the body, tangential to that plane. They are tangential to this plane. So they are shear forces, Sx and Sy. Of course, in your case, you are only dealing with vertical loads, so only Sy will be coming. But yes, Sx is also a shear force. So Sx and Sy will be a shear force. And Sz, guys, here in this direction, this force is not tangential. So this will be axial force. All these forces are internal forces. Now three movements will be coming. Also, they are also internal things because they are coming after cutting the section. Out of this, Mx and My, about the transverse axis, will be the bending moment. And Fz, you can clearly see here, movement about the z-axis. You can clearly see that movement about the z-axis will be acting like a torque. It will be producing a twist in the body. So, the forces in the transverse direction are the shear forces. Movements along the transverse axis are the bending moment. And the force along the longitudinal axis is the axial force. And the movement about the longitudinal axis is torque. Now, let me tell you, suppose this is a bar. Force P and P are acting such that the net force is 0. If we cut this section from somewhere in the between, after cutting the section somewhere from the between, not might be exactly at the center, from anywhere. If we see these individual parts, this as 1 and this as 2 individually. So, here has to become an internal force P and here also has to become internal force P so that the net force is 0. Okay, here only two forces, these white and white are coming. But here it has to become internal forces such that net force is 0. These are the axial force because it is perpendicular to the cross section there. Okay, see here these P are axial forces, but net force is 0. Net force is 0. Similarly, if you see here in this beam, Sx, Sy, Sz are shear forces. But if you see the whole beam, it will be in equilibrium. Okay. Now, as there we find the axial forces. Similarly, in case of beam, we may find the shear forces as well. But the net force is 0. Okay. Now, shear force is the summation of transverse forces either to the left or right. This is just GCPT definition. Okay. Suppose if we see a beam here and this beam is acting by these loads, net vertical direction force is 0. 10 plus 2, 12 downward, 8 plus 4, 12 upward, net is 0. So suppose we want shear force at this XX section. So it is the summation of transverse forces either from left or right. If we see from left, just see from left of XX. So one is upward. So section, this is the sign convention. This is the sign convention. Left hand side upward is taken as positive. So this is positive. And left hand side downward is negative. So 4 minus 2, this is plus, this is minus, so it is 2 from left hand side. If you see from right hand side also, it will be again same. Right hand side 10. So right hand side downward is positive 10, and right hand side upward is minus. So minus 8, it will be 2. Okay, so if you see from left, if you see from right, it will be same. That is 2. And if you now want to know the physical significance, that if I cut this section from XX section, this is the XX section, if I cut it from here, then see the net forces. 2 here downward from left hand side, 4 here upward. So net force is 4 upward, 2 upward, 4 minus 2. Net force is 4 upward and 2 downward. So making it equilibrium, here this 2 is coming downward. So 2 plus 2 in 4 downward and 4 upward. This is actually shear force. This is actually the shear force that you are getting here. If you cut from right hand side, the same answer you will be getting. So this actually is the shear force. Similarly, if I go with the bending moment, first of all, let us see the sign-on convention. Any movement due to the upward loading will be positive, due to the downward loading will be negative. Okay, from section left hand side, if it is a clockwise movement, it will be positive. From section right hand side, if there is an anti-clockwise movement, it will be negative. And similarly here, anything that is sagging will be positive, anything that will be hogging will be negative. Now you will better know the sign convention once we go actually to the bending moment. Okay, and there is nothing sagging. If you're calling this as sagging, some of you call this as sagging. This is sagging only for this person. For this person, it is hogging. So same thing for different person is sagging and hogging. This will say this will be sagging, this will say this will be hogging. So sagging and hogging depends on frame of reference. Okay, generally in case of beam, we take downward person as reference by default. Okay, actual physical significance of sagging is that where to put the tension reinforcement. Suppose something is like this and concrete is very brittle, weak in tension. So tension is bottom, so we'll put steel here. So hogging will be like this, tension will be upward, so we'll put steel here because concrete is weak in tension. Now, let me tell you the bending moment. Like shear force is the summation of forces either from left or from right, bending moment is the summation of moments either from left or from right. Suppose this is a beam, 4 load downward is exactly acting at the center. So of course, when it is exactly at the center, those supports, for a simply supported beam, it will be 2 and 2 from symmetrical concept. Now, if we take a XX section, just 1 meter from the left end, and total length of the beam is 4 meter. Now, it is the summation of movements either from left or right. If we see from the left, only one thing is there, 2. So 2 into 1 will be 2. So it is upward loading. I told you here now. I told you here for upward loading it is positive. Okay, or you can see from this sign convention also. From left hand side clockwise is positive. So either you see upward loading positive, or from left hand side it is producing a clockwise movement, it is positive. So anything it is positive. So bending moment at XX section from left is positive 2. And from right hand side also, if you see, this is 2. So 2 into 3, because up to XX the distance is 3. It is upward loading, so it is positive. Okay. Also from right hand side it is anti-clockwise movement, and from right hand side anti-clockwise movement, right hand side anti-clockwise movement is also positive. So here this will be 2 into 3 positive and 4 is downward load. 4 into 1 negative. Downward load is negative. Also from clockwise anti-clockwise you will find the same. So it is also plus 2. This is the bending moment. Okay, now what is the significance of bending moment if you want to know me? If you want that what is the significance, let me tell you. Suppose this is a XX section. This is a XX section. Here the load 2 is acting. From left hand side nothing other load is acting. So for making force equilibrium, 2 must be here downward. This is the shear force because it is tangential to that part of the body. Now it is not still in equilibrium because bending will also be there. This is 1 meter. So 2 into 1 will be clockwise due to this 2. So here anti-clockwise movement should be coming 2 kilonewton meter or 2 Newton meter. So that is the bending moment. Okay. Now I am telling you a trick from which you can draw SFD BMD of any, from which you can draw SFD and BMD of any beam just in 2 seconds. For that trick, you should be knowing some points. That upward loading, whenever there is an upward point load, shear force will jump. Whenever there is a downward point load, shear force will fall. Whenever there is a clockwise movement, BMD will jump. Whenever there is an anti-clockwise movement, BMD will fall. Slope of bending moment is shear force. Slope of shear force is load intensity. Okay, and upward loading will be taking as positive, downward loading will be taking as negative, and we'll be making our diagram from left to right. From these points you can draw any SFD BMD in this universe just in 2 seconds. This I also called as AN method, not my invention, but I usually call it as AN method, Abhinav Negi method. So please remember, upward point load shear force jumps. Whenever there is upward point load shear force jumps, downward point load shear force fall, clockwise movement BMD jumps, anti-clockwise movement BMD falls. Slope of bending moment is shear force. Slope of shear force is load intensity. Upward loading positive, downward loading negative, and we draw from left to right. These are the graphs also. I'm not going into the maths, but obviously you can see that any increasing function will be a positive slope. 1, 2, and 3 are the increasing function. Slope will be positive because it is acute angle. Slope will be acute angle, and tan of any acute angle, 1030, 1050, 1070 is positive. And of course, if you check the slopes, it will be decreasing. If you check the slopes here, angle is increasing, it will be magnitude wise increasing, and same as here. Here they will be making obtuse angle. Tan of any obtuse angle is negative. Now, with these points and these graphs, you can draw any SFD BMD in this word in just in 2 seconds. Let us take few examples. Suppose this is a beam and I want to draw the SFD BMD. Now, I will be drawing SFD here. See, upward point load, what I told you. If you want, you can take a screenshot of this. If you want, you can take a screenshot of this. It will be very interesting from now onwards. Okay, just take a screenshot of this and a screenshot of these graphs. Okay, now I'm drawing the SFD BMD. Upward point load, I'm drawing the SFD first. Upward point load, shear force will be jumping by 2 magnitude. Then A to C, there is no load. A to C, no load, and shear force slope of shear force is load intensity. And when W is 0, that means shear force. V means shear force is constant. Then 4 downward load, shear force falls, plus 2 to 4 fall, plus 2 and decreasing, falling by 4, it will reach to -2. Then again no load. And when there is load is 0, shear force will be constant. Then again upward point load. So upward point load, shear force will be jumping. Now let us draw the BMD. From A to C, shear force is positive and constant. And slope of bending moment is shear force. And shear force is positive constant. Positive constant is this graph. I just told you these graphs. So positive constant is graph like this, graph number 1. So positive and constant, it is like this. The negative and constant, graph number 4. Okay, now guys, please remember these points. This will be very helpful to draw the SFD and BMD. Now let me take one more example of uniformly distributed load of W Newton per meter. If the total length is L, then supports will be WL by 2 and WL by 2. Now, if I draw SFD first, then there is an upward load of WL by 2. Okay, so upward load, you know now, shear force jumps by WL by 2. Then A to B, loading is downward. And downward loading, I told you is negative. And shear force slope is load intensity. And load intensity here is downward, that is negative and constant. Constant magnitude of W. So negative constant, what was the graph? Negative constant was the graph like this, graph number 4. This graph decreasing, so negative slope and constant. Then upward load at B, upward load, shear force jumps like this, SFD. And if I draw the BMD, then from A to midpoint, let me name is as C. From A to C, shear force positive and decreasing. Positive decreasing, I told you, graph number 2. So positive decreasing is like this, because bending moment slope is shear force. Now, while drawing the shear force, you will be seeing the loading diagram. While drawing the bending moment, you will be seeing the shear force. So bending moment slope is shear force. So shear force is positive and decreasing here. Graph number 4. Then here the shear force is negative, but magnitude wise more. So negative and magnitude wise increasing, graph number like this. You can see from that 6 graphs. Now let me take one more example. This is the graph number 6 now, as we have drawn here. Okay, negative and increasing. Okay, let me take one more example. Suppose this is a beam. This is the reaction somewhere RA and RB. I'm not going into the values. Suppose I draw the SFD first. So here upward load RA. Upward load means shear force jump. Upward load means shear force will jump. Then loading is down. See, shear force slope is load intensity. So load intensity is downward. That means negative as per our sign convention. Negative but increasing. See, left to right we have to go now. Increasing. So negative and increasing graph. I told you negative and increasing graph number 6. So negative and increasing like this. Then upward load RB. So upward load shear force will be jumping like this. Now let me draw the BMD. Shear force here is positive, but magnitude is less. And positive and decreasing. Slow. While drawing the BMD, you have to see SFD. So bending moment slope, dm by dx is shear force. And shear force is positive and decreasing from A to C. So positive and decreasing is like this. Okay, and here it is negative and increasing. Shear force negative. We have to go from left to right. Negative and increasing. Here more. Negative and increasing, graph number 6 like this. So guys, we can find out the values also. Some other class will be going into the values also from AN method also, Abhinav Negi method also. You can find the values also, not only shape but values also. So I hope that in this video you got the significance of shear force and bending moment, and also how to draw the diagrams with a super duper trick. I hope you enjoyed this series, and guys, keep watching Ground Zero series, where you will be getting the animated videos with high quality content that will be helping you in the exam. For any more queries, you can contact me in my Telegram group, Civil by Abhinav Sir. That is the Telegram group. So do like and share this video with everyone, and let us know your feedback in the comment section. I will be eagerly waiting for that on the comment section. Do like and share and subscribe the channel for more such sessions. Thank you. Take care.